Welcome back, ladies and gentlemen. Welcome. I'm sorry the last video got cut off because I ran out of memory on my computer here. So we'll continue on for uranium here. That is 4F14 already. That's 70 electrons, right? So look at the diagonal rule. After 4F is 5D, and then 6P, 7S. All right, 4F and then 5D can hold 10 electrons. Remember, D can hold 10. 5D 10. After 5D is 6P. 5D is 6P there. 5D, you can see that in the corner. 5D and then 6P, 6, 7S2. So we keep count. 70, 80, 86, 88. We need 4 more. After 7S is 5F4. That is the address. That is the electron configuration for all the electrons for uranium. 92 electrons. It is quite a lot of electrons. So you have to be able to follow the diagonal rule. So just again, I'm going to go over the diagonal rule again before we start the next part. Okay, just review here. Diagonal rule. Remember this, the diagonal. You start 1s first, and then go back to the line. 2s, go back to the line. 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 3p, 5p. I'm sorry, 4d, 5p, 6s. 4F, 5D, 6P, 7S, 5F, 6D, 7P. Refer back to this to go in order. On your periodic table, it's fairly interesting here. If you look at this, look, row 1 is only 2 elements. 1S, 1S1, 1S2. S2 is over here, helium actually. And then 2S, 2P. The next row, 3S, 3P. 4S, 3D, 4P. 5S, 4D, 5P, 6S, and then we go down to 4F14 here. Continue that before we go to 5D, 6P, 7S, 5F, and then 6D and 7P. That is how we read on the periodic table. So the element uranium we just read was element 5F4. So we go 1, 2, 3, 4, and you'll see that 5F4 is exactly where uranium is on the periodic table. All right. So an element ending right here, right? This is 2p1, 2, 3, 4, 5. 2p5 would be fluorine. See, this will tell you where the ending is at. Okay, if you have, for example, 1, 2, 3. Let me see. Let's see the second one here. That would be 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9. 3d9, that would be element copper, which is 29 electrons. Yeah, it'll be Cu. So it'll tell you exactly where these tables are at. Okay, and I'll show you a better picture here. Let me make sure that is it currently recording. Yes, it is. Let me show you a bigger picture here on the screen. Get my face out of the way. All right, so you see here, you'll find this table on the internet. So as far as it goes, that's where it should end. You should keep going, follow the diagonal rule until you reach that point. Okay, and so with practice you understand it a little better. And as we continue here, hover cam. So we go down to the bottom. Right now they give you the configuration. Let me focus here real quick. So they'll give you the configuration. Your turn to find out what element that is. Right. One way is to add up electrons. 2 electrons. Add up all the little bitty number on top here. 2, 4, 10, plus 6 is 10, plus 2 more is 12, plus 6 more, 16, plus 2 more, 18, 28, and 32. 32, am I right? 32. So element number 32, so if you look at 32 electrons, look at that. No, I did something wrong. Should be 34. Should be 34, not 32. Let's add that again. 2, that's 10, that's 20, 30, 34. Yeah, so that's 34 electrons. And element number 34 is Se. Okay, that's what you do those. All right, so if you were to look at, let's pick a long one. Look at E here. E looks like a mess, right? So we know from the previous one to this point, this is 10, that's 20, 36, 36 plus 2 plus 10 plus 6, 36 plus 18, that's 54. So keep counting. 54, 56, 70, 80, 86, that's 86, 88, 102, 110. Element 110. And if you look, element 110 is that element right here, ds. Okay, element ds. And so look, it ends up in row 7, which is remember, I haven't told you this, but the d. So this is the first two columns, 6s, right? But the d section here is going to be one less, 6s 5d, and then 6s 4f is going to go between 6s 5f 4f. I'm sorry, 6s 4f and then 5d. The d is always one lower than the row number. So this is row 7. 7s is on the same row. Row 7 will have 7s. After 7s, it's going to be row f is going to be 2 lower, 7s, and then 5f, and then back to 6d. So this is row 6d here. 6d 1, 2, 3, 4, 5, 6, 7, 8, and 6d8 is correct. It's the 8th element on the 6d section, 6d block. Remember, s is on the same row number. So this row will start out with 1s, 2s, 3s, 4s, 5s, 6s, 7s. It's going to start at the s. All right, the s orbital. But the d, once you get to d, remember this is 4d, this is 5d, this is 6d, this is 7d. Oh, I messed up. I messed up somewhere. This is 3d, I'm sorry, 3d. Man, I'm getting confused, a little bit confused right now. So 3d, 4d, 5d, 6d. It starts at 3d, not 4d, okay? So 3d, 4d, 5d, 6d. So this element would be, it would end as 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 49. This element manganese here would end as 3d, 1, 2, 3, 4, 5, 3d, 5. So the f, though, is going to be 4f and 5f. It's 2 rows less than the row number. Okay? 2 levels less than the row number. Let's just use different words there. 6s and then 4f and then 5d. We follow the diagonal rule. 6s, and then 4, back to the line, 4f, 5d. Remember. And then 7s, what's after 7s? Go back to the line, 5f, 6d. 5f, 6d, back to that. Remember, this bottom part here is supposed to stretch the table out. It's supposed to look real ugly. So it's, let me sketch it real quick. So we got 2 columns here, right? And it's supposed to stretch that table out, and then your transition metal, and then your other groups over here. So that those 2 groups are the 4f and 5f are supposed to be here, stretching the periodic table out. But just because it looks nicer, look more organized on one sheet of paper, they took it out and put it at the bottom. So technically, it's supposed to be a very long table. Okay, so you have your S, your F, your D block, and your P block all the way over here. So anything in this 2 column is going to be S. Anything in this part is F. The transition metal is your D block. Not, I'm a little off today. And then your P block is over here with all your group 13 through 18, with the exception of helium. Okay. So on these, you count up the electrons. I can easily spot it. For example, J here, 5p3. So P and S are the same as the row number, 5p3. So 5s and P, 5p are in the same row. So 5p is over here. So this is 2p, 3p, 4p, 5p, 6p. So P corresponds with the row number as well. So 5p3. So I can immediately 1, 2, 3. That's SB, right? SB. I can confirm it. By, so here you'll see a different notation here. On J, it tells you it's krypton, and then you add on these things, right? Krypton is 36 electrons, okay? And then we're going to add on 2, 10, and 3. That's 15 more. 36 plus 15 more electrons, that'll give you 51 electron, which is SB antimony. It is SB. It is antimony right there. Okay? Pretty straightforward. For example, here XE Xe xenon is 54 electrons. We're looking at N right now. Xe is 54 electrons. We add on 2, 14, 7, that's what? 23. So 54 plus 23, that'll give us 77 electrons, which is 77. Atomic number is IR. And you can confirm, look. 5D7. IR is on row 6. Yes? On row 6. D is always one lower, so 5D1, D2, D3, D4, D5, D6, D7, 5D7. It matches perfectly to the table there. Okay? That's that part. Beautifully done. Okay, that's we'll end the second video here. So finish this section, should be fairly easy. Check with your teacher for the answers. Make sure you're doing this correctly. So good luck and have fun.